All right, so 12.1 is the counting principle. First thing we start off with is the definition of experiment. All right, so the experiment is an activity with an observable outcome. So an example of that flip is flipping a coin. Your sample space is going to be all possible outcomes of an experiment. So in this case, if we stand with the example of flipping a coin, heads and tails will be your sample space. Sample space is usually denoted by the letter S. And I believe you go on with the event. All right, so an event is going to be any collection of outcomes from the sample space. Example of that is tails. If you want to know the probability of landing tails, tails would be your event. That's usually denoted by a capital letter. So in the first example, All right, so one number is chosen from the sample space, and that sample space is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. List the elements in the following events. So the number is even. So your event is the number is even. So just take all the even numbers, or list all the even numbers in the sample space. So 2, 4, 6, 8, and 10. Next one, the number is divisible by 5. Just talking about 5 and 10. And the last one, the number is prime. Talking about numbers that are only divisible by 1 and itself. Oh, left off 2. 1, 2, 3, 5, and 7. Yep, that's it. Questions before we go to the next one? As a matter of fact, that's right. 1 isn't considered prime, so it should just be 2, 3, 5, 7. That's my fault. 2, 3, 5, 7. All right, let's go to the next one. All right, so two-digit numbers are formed from the digits 1, 3, and 8. Find the sample space, and that sample, like a 6, should be just writing that better. Find the sample space and determine the number of elements in the sample space. So one of the ways that may help us figure this out is by creating a chart. And we can use the digits 1, 3, and 8 to create a two-digit number. right. So 1 and 1, 1 3, 1 8, and 3 1, 3 3, 3 8, 8 1, 8 3, and then 88. So 9 elements all together in the sample space. All right. Questions?
Would it be wrong if you switch the numbers around? Like
Say
instead
it
of
again. You're a little low.
would it be wrong if you switch the numbers around? Like instead of 18, you put like 81.
Nope, because at some point, even if you rearrange them, you would come up with those same digits. They might be in different orders, but you'll still come up with those same 9 numbers.
Okay.
Yep. All right, so let's look at another one. All right, so a true-false test consists of 10 questions. Draw a tree diagram to show the number of ways to answer the first 3 questions. So, key thing here is they tell us a tree diagram and also the first 3 questions. So we're not looking to do a tree diagram for all 10 questions, just the first 3. All right, so when it comes to the first question, you have 2 options, of course, true and false. So after you answer true, you have 2 options, true and false. After you answer true again, you have 2 options, which is true and false. If you answer false for the second question, you have still 2 options, true and then false. Down here. So if you answer false first, 2 options, true, false. True and false comes down here. True and false down here. right, so that would be all 8 ways of answering the first 3 questions. All right, questions before we go to the next one. All right, so the fundamental counting principle, if you can choose one item from m items and one item from n items, the number of 2 item choice is going to be m times n. All right, so if you have 30 shirts, 20 pairs of jeans, 10 pairs of shoes, how many different outfits could you create? And so we're assuming that you're not going to double up on shirts or double up on a pair of jeans. You're only going to wear one shirt, one pair of jeans, one pair of shoes. So it'll calculate how many outfits that could be created. Of course, this doesn't give an account for you would not wear this type of shirt with this type of pants or whatever. We're just talking about just how many different outfits could you create, not worried about matching or whatever. So there's just one out of each common category. That'll be 30 times 20 times 10, which would be 6,000 outfits. So, next time you say you don't have anything to wear, mathematically it's probably not incorrect. Probably could figure out another combination if you wanted to. All right. So once again, we multiplied the number of options we had in each category. So there were 30 shirts, 20 pairs of jeans, 10 pairs of shoes. So we multiplied the number of options from each category. As a matter of fact, I might write that just in case it come up. All right, so multiply the number of options in each category from each category. Yeah. So. All right, so in horse racing, betting on a trifecta refers to choosing the exact order of the first three horses to cross the finish line. If there are 8 horses in this, how many trifectas are possible, assuming there are no ties? All right, so there are 8 horses, and we have first, second, and third place. And I want to choose or figure out how many different ways could I choose for first, second, and third place. But if there are 8 horses, then I have 8 options for first place to choose from. Now, when one crossed the finish line, that means in my second option, I'm going to have 7 horses to choose from. Then once the second place crossed the finish line, I will have 6 horses to choose from. All right. So in each category, on first place, before any horses cross the line, I have 8 horses to choose from because there are 8 horses in the race. Once one of those cross the line as first place, I have 7 horses left. One, after you figure it out or establish that, you can go ahead and multiply those 3 together. And it should be 336. Yep. 336 plus. For 336 possible trifectas. All right. Questions before we look at the last one? All right. So from the letters A, B, C, D, and E, got 5 letters here. How many 4-letter groups can be formed if a letter can be used more than once? And each letter can be used exactly once. So once again, we have 5 letters to choose from. And I'll do that. 5 letters to choose from. And each letter can be used more than once. And we want 4-letter groups. So we're looking at just 4 boxes. So if each letter can be used more than once, that means I have 5 choices in each box. That means it's possible for all of them to be A if I wanted, and so on. So go ahead and multiply those together. That'll be 625. Remember what goes in the box is how many choices you have for each category. So looking at B, the difference here is that you can only use each letter exactly once. So I have 5 letters to choose from. So in that first box, we have a 5. I use one and I can only use one, that's one in that box. When I get to the second one, I have 4 choices. Once I get to the third, I have 3. And then last one, I have 2 choices. Multiply those together, that's 120. All right, questions or concerns? Excuse me. All right. Well, that's it for 12.1. If you are good and I'm good, make sure you get with me. If you have any issues, or questions or concerns, always feel free to email me. If we have to set up an office hour or anything like that, that's always open. Um, just have to coordinate our schedules and go from there. So I will see you guys on Friday. Have a good day.